So today we'll look at two types of organic reactions. Not organic reactions, but how organic compounds that can actually usually breaks into in two types of ways. So there are two ways in which covalent bonds in organic molecules, it's very important, can break. So first of all, we have homolytic fission. So there is two part. One is homolytic and there is fission. So homo means same or equal. So when there is so we know that a Cl atom, have a look at a Cl atom. So a Cl atom or a Cl2 molecule, they have, this Cl molecule has 1, 2, 3, 4, 5, 6, and 7 electrons. So they need one more to make a bond. So in their outer shell, so that in the outer shell they have 8 electrons. So when these two molecules break, what happens is this were the bonded pair of electron. So the name homo suggests that during the fission they they break down or they take away equal amount of electrons. So the bonded pair, in the bonded pair of electron there are 2 electrons, so now each one will take one of them. So that's how the homolytic fission works. So this happens in the breakdown of Cl in the atmosphere to form Cl radicals. If you provide UV light, and it proceeds to the formation of radical. So this thing that you're getting is called a radical. So let's look what radical is. So the breaking down of a covalent bond so that atom get one electron from bonded pair of electron uh, leads to the formation of free radicals. So if you have a deeper look, what we can say is that it's not an ion, rather it's just the natural element. Cl has naturally 7 electrons. However, what happens is, what we can see is that it is not stable because the outer shell is not full. So it's in such a state, this atom is in such a state that it is very reactive. So it may readily react with anything that uh, it may readily react with hydrogen and any chlorine that is in the atmosphere. So this very reacting atom is now called a free radical. So the definition goes like this: free radical, they are very reactive atom or molecule with a single unpaired electron. So we know that they're reactive because they are not full, so they have a single unpaired electron, and they're usually formed when homolytic fission has occurred, like through this, when UV light is given they break down. So usually formed by homolytic fission, where the bonded electron is divided into two. So moving on, the other type of breakdown reaction, we call this as heterolytic. So hetero is the opposite of same, so it's actually unequal distribution. So in here one atom is dominating, so the breaking down of a covalent bond such that the bonding electrons, so for suppose for A and B, this dot and cross were the bonded electrons, but they're taken by only one of the atom, they are not equally shared. So both of the electrons are going to be. So what we get is that we get ions now. Note that we are not getting radicals, however we are getting ions, and these are like fully charged as they are losing electrons, and the other one is actually gaining electrons. So these are now ions rather than radicals. So these were the two types of these were the two ways through which organic molecules could break. Now let's have a look at two other type of uh, ways we can group molecules into. So one is the electrophile and other is the nucleophile. So let's have a further look into it. So nucleophile is a molecule, you can say. Nucleophile, uh, actually the